Hello there. So today we're going to continue on in our unit about triangles. We're going to be looking at one of my particularly favorite theorems today, and you'll see why when we get to practice with it. Just so you know, today in this lesson, there's 4 things you have to be aware and make sure that you're doing throughout the process. First of all, get your notes that you got handed out in class today. You want to fill out these notes as you watch the video. You want to make sure you're watching the full video. Complete the remaining exercises on the worksheet. Don't worry, there aren't that many. And then you can check your answers with the key online. I highly recommend you do that. That way tomorrow in class we just hit the ground running with a new topic related to today. So our goal today is how can we determine if any 3 side lengths will form a triangle? So if you take a look at the diagram below, this certainly is not a triangle. On the left here, the side lengths are 2, 6, and 3. So there's something about these numbers that just aren't making a triangle. If you look at an example that is a triangle, the side lengths are 3, 6, and the longest side here is 8. So 2 of the numbers happen to be the same in the non-triangle example, but something special is happening. There's a special theorem we're going to explore today to help us figure out what it takes for 3 side lengths to form a triangle. So to get started today, we're going to look at this theorem. I told you, this is my favorite one, triangle inequality theorem. So you want to fill in these notes as you're watching along. So here are the fill-ins. In order for 3 sides to form a triangle, the sum of any 2 sides must be greater than the measure of the third side. Okay? So the sum of any 2 sides must be greater than the measure of the third side, and that will give us a triangle. So you're probably thinking, well, what does that mean exactly? So here's an example of a triangle. Remember, we can label sides of a triangle by the angles that they're opposite from. So here I have side A is opposite angle A, right? Side B, that's across from angle B. And I have side C here on the left. That's opposite angle C. All right, so what this theorem tells us is if we take any 2 sides and add them up, so let's take A plus B, right? A plus B has to be greater, that sum has to be greater than the length of C. And this should work for all 3 cases. So B plus C, those 2 sides should be greater than A. And what's left here? We have A and C we haven't added yet together. So A plus C, those 2 sides should be greater than B. And if these all check out, you have a formula that will give you a triangle. Let's take a look at what that looks like with numbers, because it's a little confusing when you just look at it with side names. So let's take a look at this example here. Okay, these are in your notes. I have the triangle theorem stated here again in case you need to refer back to it. We're considering the following triangles. So let's see if these check out. Let's see if these 3 sides, this 3, 4, and 5, actually do make a triangle. So to test that, I'm going to take 2 of the sides. Let's take 3 plus 4 and see if it's greater than 5. Well, 3 plus 4 is 7. 7 is greater than 5. That one checks out. Let's try another set of sides. Let's try 4 and 5. So 4 plus 5 should be greater than 3. Well, 4 plus 5 is 9. 9 is greater than 3. Okay, that one checked out nicely. So let's see what's left over. The only 2 sides that we haven't checked yet are 3 and 5. So let's add those 2 up. 3 plus 5. In a perfect world here, if we're trying to get a triangle, should be bigger than 4. 3 plus 5 is 8. 8 is greater than 4. So that checks out too. We know that this is a triangle by the triangle inequality theorem. Okay, please notice here, I'm going to get the highlighter tool out. You want to notice here that this inequality I'm using in all these cases is the greater than symbol, strictly greater than. It can't equal the other side, it has to be bigger. So even if we had here, even for down here, if we had 8, if we ended up somewhere with like 4.1 greater than 4, well, that's true. But if we ended up with 4 greater than 4, well, now we're running into a problem. This wouldn't make a triangle, okay? So that So you want to make sure it's strictly greater than. That's a really important detail. So let's continue on with a couple examples. We're going to do these 4 examples together, then you have your worksheet to try on your own. So if you take a look here, they want us to determine if the following side lengths would form a triangle. We just have to say yes or no. Now I'm going to give you a little shortcut here to make this a little bit faster if that's what you're interested in. So if we go back to the last example, the only 2 sides that we should have been a little worried about were the first ones that we checked. Okay? The reason why we want to be a little more careful here is because 3 and 4, those were the shorter 2 sides. So they would come up a little bit shorter than the biggest side of the triangle if this wasn't a triangle. So if you ever want to test the triangle inequality theorem, you could always test it with the shortest 2 sides and see if they're bigger than the largest. Okay, so let's try that out here. Shorter 2 sides in a 7, 5, 4 possible triangle. We're going to see if 4 plus 5 is greater than 7. I like to do a little question mark above my inequality because that's telling me, remember, you're testing this. You have to come up with a determination. So 4 plus 5, I'm going to do my work here. 9 is greater than 7. So this is a triangle. It's good to write a little sentence here. This is a triangle. Okay, let's try example 2 now. Example 2, 3, 6, and 2. So I'm going to take the 2 shorter sides, 2 plus 3, and test to see if they're greater than 6. 2 plus 3 is 5. Is 5 greater than 6? Hopefully you're thinking no. So we can say not a triangle. Let's take a look at 5, 2, 4. We're going to take the 2 shorter sides, 2 plus 4, and test to see if they're greater than 5. All right, 2 plus 4 is 6. 6 is greater than 5. So this is a triangle. And now our last sides, this is an 8, 2, 8 triangle. So this would be, you can imagine it would be an isosceles triangle because 2 of the side lengths are equal. So let's test it. Whenever you have a repeating number, just count one of them twice. We get 2 plus one of the 8s should be greater than the other 8. 2 plus 8 is 10. 10 is greater than 8. So this is a triangle too. So in this case, we only had one that didn't work out to be a triangle. It could happen either way. A lot of times you'll see this as a multiple choice question. So watch out for that when you do your worksheet now. I'm going to go to this next slide. So now that you have watched the video, you have some examples to try on your own. Once you're done, remember to refer back to the answer key. And just a little looking ahead for tomorrow in class, we're going to be discovering, now that we know if 3 sides determine a triangle, we're going to have to deal with this. If we know 2 sides, how can we determine a possible length for the 3rd side? So we're going to be dealing with the unknown tomorrow, so you really want to brush up on the triangle inequality theorem today. Thank you for watching the video, and good luck with your worksheet. Don't forget to check your answers, and I'll see you guys tomorrow in class.